Okay, so I'm just going to look at the diagram, and we're going to look at it without replacement. Okay, you could do this without a tree diagram as well, so I'll run through that as well. But you have to draw up a tree diagram. But sometimes in a 2-unit paper, you could be asked to complete a tree diagram, so it is handy to know it as well. And it's just a good way of sorting stuff out. Okay, so we have a bag, and in the bag we have 3 red and 5 blue. So we're going to make 2 draws. So that means like this is your first draw. Okay, you could get a red or you get a blue, and your second one you could get a red or a blue, or you could get a red or you could get a blue. Now on the probability tree, we're going to write down the probabilities. So on the first draw, you've got 3 reds out of 8, because there's 8 in here altogether. That means there's 5 out of 8 blues. Now, when you go up one line here, and that's a red, you've taken a red out. So it's actually good to do the reds first. So if you take a red out, that's 2 on 7. And then what I usually do is just put 7 and 7 on both of those branches. And that's 2 on 7. And you've got to look what goes in this space here for the blue will be what makes up one whole. So that's 5 on 7. And you can also see if I take out one out of there, I'll have 2 reds, but I'll still have 5 blues left. Okay, and then looking at the next one, that's 5 on 8 blues. That means if you go down, if you're going to do this, you need to go down that line. So blue and then blue, because I'm taking a blue out, so that will impact how many blues are left. So there's 4 blues out of 8. That means on the other one, there will be, so it starts off 5 blues out of 8, and then we take one out, so it's not out of 8, it's out of 7. That's why it wouldn't add up, because I took one out and I haven't put it back. So that means there'll be 3 out of 7 left. Okay, so you do have to, that's a good lesson in making a mistake. So just double check that it all adds up. It's got to add up to one whole, and it will be out of 7. It will decrease because it's without replacement. Okay, so once you've got your tree set up, you can just use your probability tree. So when you're using your probability tree, you multiply along the separate branches, and then you add the separate events. Okay, so let's just look at this first one here. Okay, so we want the probability of a red and a red. So that would be going along this branch. So it'd be 3 on 8, and you could think about that without a tree too, because there's 3 red, 5 blues. So there's 3 on 8, so there'll only be 2 reds left out of 7 balls. So that ends up being 3 on 28. Okay, 2 the same colour, so you could go probability of red, red, or the probability of blue, blue. Okay, so if you're using your tree, probability of red, red could be 3 on 8 and 2, 3 on 8 times 2 on 7, plus, now blue, blue, 5 on 8 times 4 on 7, 5 on 8 times 4 on 7. And see, they are 2 separate events. You either get one or you get the other. You can't get them together. And that's why when you're doing that, you can just use the rule where you can add the 2 separate events together. And see how you add the 2 separate branches from the probability tree. You could also, on your probability tree, you could also write at the end of it the different outcomes that it's actually given you. And if you wanted to really use your tree, you could also write at the end of the tree, you could also write the probabilities, like 3 8s times 2 7s, 3 8s times 5 7s, 5 8s times 3 7s, and 5 8s times 4 7s. And if you added all this up, what do you think that would equal? Yeah, it would equal one whole. Okay. So you end up 13 on 28. Okay, so part 3, at least one red. So 1 minus the probability of no red. So it's 1 minus the probability of blue, blue. So 1 minus, now blue, blue is 5 on 8 times 4 on 7. And you end up with 9 on 14. Okay, so in a raffle there are 200 tickets. So 6 of them are winning tickets for Amala and 194 are losing tickets for her. So we're interested in what she does. So if we want the probability that she wins. Now, we could do a probability tree. If we were going to do a probability tree, it'd be win, lose. That would be the second prize. And then win, lose, win, lose. That would be your first prize. So that's the first, the second, and the third. So on the first branch, she'll win a prize. That would be 6 on 200 and 194 on 200. So if you went up the win one there, she'd only have 5 on 199. And then you go to the next one, that's 4 on 198. Now, every time you do this, it's got to add up to one whole. So instead of thinking about what it would be, you just make sure that it adds up to one whole. So that'll be 194. Okay, when you come out on this branch here, that's 198. We could fill that out because that's got to be 194. Okay, because that makes 198. So let's just go up this branch. You got 194. These are going to be on 199. So lose, that'll be 193 because there's one of those tickets. And this would have to be 6 on 199. And then when we keep going here, these will all be on 198, won't they? 198, 198. See, it's sometimes it's easier without a tree, but this is just to give you an understanding of what you could do with the tree. Okay, so if you're looking at, I'm just going to highlight it because I think it makes it easier. This one you win, that's done. Win, lose. Win, lose. Okay, win, lose. Now, if we did win, lose, that means that there would only be 194 tickets left. So you're better doing that first, and then there'd be 194 tickets left. Sorry, take that back. It would be 193 tickets left. And then that means that this here would be 5. There'd be 5 winning ones. When we're looking at the next column here, which you can't really see real well, I'm just going to rub that out. And let's just go for... So that was win, lose. Yeah, so it'll be win, lose. It's hard to see, isn't it? So that's lose, win. Yeah, no, that isn't there. That's fine. So that's the winning one. So if we go in there, we're going to go, and I'm just going to highlight it so that'll make it easy. We'll do it in yellow. So if we're going up this branch, it would be lose, win, and then you're better off doing the win. So when you're doing that, lose, win, there'll be 5 out of 98. And then 5 plus what gives you 98? That would be 193. Okay. And if you look at that, the 193 here matches with the 194 because one of those came out. Now, if we come down here, we go lose, lose, and you're better off doing the lose better. So that's going to be 193. That'll be 192. Okay. So if that's 192, that must be 6 there. So it can be it's more complicated sometimes doing the probability tree, but I just want you to have a look at it, what it would actually look like. Okay, so win. So she would be 6 on 200 times 5 on 199 times 4 on 198. Okay, win at least one prize. So 1 minus lose. So it's 1 minus. If she loses, it's 194 on 200. 193 on 199, 192 on 198. Okay, and she wins at most one prize. That would be lose, or she wins at most one. So that means you can't win all. She could do lose, or she could win one. So she could win, lose, or she could lose, win, lose, or she could lose, win. Okay, so that would be, now there is 6 winning tickets and 194 losing tickets. So lose, lose, lose with 194 on 200, 193 on 199, 192 on 198, okay? Plus winning would be 6 on 200 times 194 on 199 times 193 on 198. And you could do the other 3, or you could realise that you could just times it by 3 because there's 3 separate possibilities. Because you look, if I do lose, win, lose, lose would be 194 on 200 times 6 on 199 times 193 on 198. Do you notice that they are exactly the same on the top? They're just in a different order, and the order of multiplication doesn't matter. The bottom ones always just stay the same. So because you can see there's 3 separate possibilities, if you just multiply by 3, it actually makes it a little bit easier. Okay.